Thank you, Chair. Good afternoon, everyone. Lion populations have been declining across their range. Over the past 21 years, lions have undergone a reduction of approximately 43%, and this has mainly been due to human-induced habitat fragmentation and prey declines. In South Africa, on the other hand, the free-ranging lion population has continued to grow. This is mainly because South Africa are actively managing their free-ranging lions across a continuum of landscapes and constraints. The Biodiversity Management Plan for Lions further recommends the implementation of a meta-population management plan for free-ranging lions, specifically in our smaller reserves. For a meta-population to be functional, there are three critical features that need to be present, and that is discrete patchy habitats within which local interactions occur with a possibility for dispersal from one patch to another. As a whole, then, these populations have a higher chance of persistence than individual populations on their own. We use the South African lion population as a case study to test whether lions meet the criteria for a meta-population. To do this, we assessed how well South Africa's small lion reserves comply with various meta-population criteria. We illustrate the management-induced connectivity and evaluate how population growth rates perform with and without management interventions. And then finally, we reflect on the importance of conservation management to overcome ecological constraints of evolved species-specific responses to fragmented landscapes as a model guiding large carnivore conservation. We sent out questionnaires to all managers of all state and private land that had lions present for any number of years from 2010 to 2019. In these questionnaires, we extract information on introductions, translocations, and the management of lions on a specific property. Additional information was also gained from the Lion Management Forum database. To understand the fragmented lion management approaches taken on the different properties, we also collated data on management interventions per property per year. And then finally, to evaluate the meta-population functionality, we assessed if lion populations in our data set comply with the classical criteria for a meta-population as recommended by Hansky in 1999, as well as the more lenient criteria that Elmhagen and Ungeborn suggested in 2001. To be able to evaluate our properties, we needed some standards to guide the criteria. And we set up two sets of standards for no active interventions and inactive interventions. So if we look at the four criteria, Hansky's first criteria is dispersal occurs between local populations. So here for no active interventions, there would be the natural arrival or leaving of individual lions. And of course, with active interventions, that would be the introduction or removal of individual lions. The second criteria is about extinctions and colonizations taking place. So for no active interventions, it will be the natural arrival of lions where there were no lions before, or the natural disappearance of all lions. Active interventions would then be the introduction of lions where there were no lions before, so near properties entering the meta-population, or the removal of all lions from a property. Hansky's third criteria is the dynamics of local populations on asynchrony. Elmhagen and Ungeborn suggested that this should be local populations should have dissimilar growth rates. So here we looked at the variance of population growth together with that of the 5 closest reserves. For no active interventions, the ratio of managed R to potential R in the absence of management should be smaller than 1. For active interventions, the ratio of managed R to potential R in the presence of management should be larger than 1. The final criteria for Hansky is habitat patches support local breeding populations with colonizable vacant habitat, and Elmhagen and Ungeborn suggest that this should be breeding local populations should be discrete rather than inhabiting discrete habitat patches. So again, for no active interventions, this would be the closest reserve is more than 5 home range diameters away with no physical barriers in between, or for active interventions disregarding the distance to closest reserve, there is a physical barrier in between, which is the typical situation we find in South Africa with all our properties being fenced. So 49 of the 59 properties completed the questionnaire. This equates to roughly 771 lines on these properties. The distance to the nearest property with lines range anything from just over 2 kilometers to just over 250 kilometers. To evaluate the first criteria, dispersal occurs between local populations. We specifically looked at the translocation events that took place between the different properties. And if we look at the graph on the left-hand side, we can see that our translocations over time have increased. And this is mainly because of probably because of three reasons. One, our lion population are increasing, so there's more lions that do need to be moved around. Two, more properties have joined the meta population. And this also leads to three, more compliance with the meta population criteria. The bar graph on the right shows the origin and destination of the different translocations and the number of lines being moved around. So we can see that KwaZulu-Natal has the highest number of lines leaving the province, as well as the highest number of lines coming into the province. But all the provinces, specifically the provinces important within the lion meta population, has had quite a lot of movement. When we look at our translocations broadly, we can see that our lion meta population has not only contributed lions to the South African meta population, but lions have also been translocated outside of South Africa, contributing to populations in Mozambique, Malawi, and as far as Rwanda. Zooming into our local population, we can see that there's extensive movement between the various properties. And again, KZN showing up 113 translocation events. Looking at our population growth with and without interventions, we can see that the regional variance in the growth in the presence of management is greater than the regional variance in the expected growth in the absence of management. And this is depicted by the graph on the right, where we can say that the asynchrony under management is larger than with no management, and that we have a slope greater than 1. Lastly, evaluating the metapopulation functionality, we can see that our properties comply with all four categories of the metapopulation criteria, and the majority of our reserves complied with 3 or more of the criteria. So our key results is that the South African lion metapopulation can be considered a functional metapopulation in that we have a landscape of lion populations linked by interventions. We have asynchrony in our population dynamics or dissimilar growth rates. And there is also a high level of compliance between our properties with the criteria. So why do we have this pattern? Well, firstly, relatively few studies has explicitly evaluated compliance with the criteria. And then even fewer looked at compliance because of management. Yet there's many metapopulation management plans in existence. For example, just in South Africa, we have the cheetah metapopulation management plan, the wild dog management plan, and then internationally, there's several more metapopulation management plans. In South Africa, we did not have an explicit metapopulation plan until very recently, and a lot of the interactions, management interventions taken place long before the implementation of our metapopulation management plan. So overall, what we can say is that our outcome of compliance was largely unplanned. Even though our compliance is unplanned, we definitely achieved conservation outcomes. And South African metapopulation is contributing over 770 lions to the African continent. And by embracing this gradient of maintaining, restoring, and mimicking dynamics, we've added value not only to our own lion population, but also to that of the continent. And it's our belief that this approach could contribute to other local and then regional challenges, such as the cheetah metapopulation, but then also country issues like that of West Africa. A key concern, however, is the uncertainty and risks associated with haphazard approaches. Here we got 4 options. Option 1 would be continue to comply accidentally to the meta-population criteria like we're doing now. Option 2 would be just to ignore it and there's no meta-population management. Option 3 would be a legislative approach where we regulate and enforce implementation of this meta-population and compliance. And option 4 is creating an enabling and facilitative environment where compliance is incentivized, for example, through a certification scheme. But for this, we require robust governance. Improving and facilitating governance could benefit, though, from understanding the present compliance to governance and the various roles and responsibilities of our different stakeholders. By enhancing compliance through good governance, this will improve structured compliance with our meta-population criteria and is likely to lead to improved efficiency and robust lion conservation outcomes. Thank you for listening. I would like to acknowledge my co-authors, Dan Parker, Sam Ferreira, Johan Kruger, Brent Coverdale, Susan Miller, and Gareth Tate, and then also all the landowners and managers of all the properties with lion on them, the Lion Management Forum, and all our provincial conservation authorities that assisted us in providing data for this project. Thank you.